Now in the previous video we talked about the brute force approach for figuring out the limiting reagent. This was done by calculating the yields off each of the individual reactants. Now this works pretty well if you've only got a couple reactants, but let's say you've got a really large number of reactants. So you have something like ammonia and water coming together with CO2 to form ammonium carbonate. It can be a bit daunting to figure out which one's the actual limiting reagent. So another approach we can use is the one determined by looking at the reaction coefficients. So let's go back to the ammonia problem we dealt with in the brute force approach. Let's take our nitrogen gas and our hydrogen gas and react them to form ammonia gas. And again, we're going to start with our 42.1 grams of N2 and our 8.15 grams of H2. Now, in the previous video, we went from moles to mass, or from mass to moles. So we're still going to do that. 1 mole of N2 for 28.0 grams of N2. For every mole of H2, we've got 2.01 grams of H2. So nothing's changed so far. We're still doing mass to moles. But in the video before, we converted to the amount of ammonia. So we had 2 moles of NH3 for every 1 mole of N2, and we had 2 moles of NH3 for every 3 moles of H2. And again, our numbers in this case, our 2 is coming from our reaction coefficient, our 1 is coming from the nitrogen, and our 3 is coming from the 3 in front of hydrogen. Now, again, the last video we kept going forward and we converted to grams of ammonia. So we'll do that here. We've got 17 grams of ammonia for every 1 mole of NH3 and 17 grams of NH3 for every mole of NH3. But what I want you to see is that really nothing changes. The only difference between the top and bottom are the first 1.5 steps. So in our first step, we convert to mass to moles. The only difference when we figure out the yield of ammonia is that we're dividing by 1 here and dividing by 3 here. And this is the reaction coefficient, which has units of hydrogen, moles of hydrogen, or moles of nitrogen. So if this equals some number, we'll say A and B. And now we start pulling things over. So we're going to get rid of this step where we convert from moles of nitrogen to grams of hydrogen. So we've got 1 over 17, 1 over 17. And we're only going to divide by the coefficient on ammonia. So we're just going to leave that with 1. So we've got times 1/2. Well, this is just a constant. And so really we can say that this equals A times some constant and B times some constant. But if A is smaller than B, A times a constant is still going to be smaller than B times a constant. So this is where the second method works. What the second method says is that you don't actually have to go figure out the yields. To figure out the limiting reagent, all you have to do is take your starting masses, convert to moles, and then divide those number of moles by the reaction coefficient. So in the case of nitrogen, we've only got to divide by 1, moles by 1. In the case of hydrogen, we need to divide the moles of hydrogen by 3. Whatever number is smaller is going to be our limiting reagent. Now this becomes a lot quicker if you look at something like ammonia and H2O going to CO2, with CO2 to form ammonium carbonate. So if we had 2 NH3 gas plus water plus CO2 going to NH4 twice CO3 solid, and I gave you 15.2 grams of NH3, 12.8 grams of H2O, and 15.6 grams of CO2. Instead of having to figure out the grams of NH4CO3 for every single one of these molecules, all we have to do is first convert from moles to grams. So for every mole of NH3, we need 17 grams of NH3. For every mole of H2O, we only have 18.0 grams of H2O. And for every mole of CO2, there's 44 grams of CO2. The next step is just to divide by the reaction coefficient. So in the case of ammonia, we've got a 2 in front of the ammonia, so we're going to divide by 2. In the case of water, we've got a 1, so we're going to divide by 1. In the case of CO2, we've got a 1, so we're going to divide by 1. Whichever of these numbers is smallest is going to be the limiting reagent. So if we go through the math, what we find for ammonia is 2.71. For H2, we get 0.711, and for CO2, 0.345. Because NH3 is the smallest number here, 0.271 versus 0.711 versus 0.35, this is the limiting reagent. Now you could go through and convert to grams of NH4CO3. And what you get is that NH3 would give you 26.1 grams, HO will give you 68.3 grams, and CO2 would give you 34.0 grams. But it's a lot of additional work that really doesn't give you any more information. So this is the second method. Go from mass to moles and then divide by the reaction coefficients.